Hello everybody, my name is JNovak. I am an online student and today I'll be discussing my project on extracting important product features from Amazon reviews. The motivation for this project is that with text reviews, these provide a lot of relevant information and insight into products, but it can be extremely hard to look through all these text reviews and pull out that information. And so my motivation is to actually be able to extract that information, which can help both consumers and producers. So with that, there's three kind of goals with this project. The first is kind of building off of case study 3, where I'm going to build a predictive model that uses the text to predict a positive or negative rating. And then from these models, I'm going to try and extract the product features, which would be the most important terms that are used to classify this text as positive or negative. And then the third kind of goal is just to use the first two goals and look at the text mining process overall and compare it to different items and see how well it works for some items and maybe not so well for other items. The data I will be using is Amazon reviews and ratings from Professor Julian McCooley's website, which provides about 80 to 83 million reviews on various Amazon products. I'll be focused on 5 specific items. Each of these items have at least 2,000 reviews. And the first item is a Hoover Tempo Wide Path Bagged Upright, which is pretty much just a Hoover vacuum. The second is the first Twilight book. The third is a Garmin Nuvie GPS navigator, just a standard kind of GPS navigator. The fourth is the Draw Something app, and finally the fifth is the Wreck-It Ralph Blu-ray. The tool I will be using is Python, and I'll be using the packages NLTK and Scikit-learn. The first step was to actually classify the data. The Amazon rating scale is 1 to 5, and intuitively you would think that a neutral rating would be 3 and anything above it would be positive, anything below it would be negative. However, this assumes a normal distribution when if you actually look at the distribution for ratings for the items that I'm looking at, they're actually highly skewed. So instead I ended up z-normalizing the ratings and I chose the neutral rating as the one closest to 0. And then I classify positive and negative reviews according to that. The data set will only consist of positive and negative reviews. The neutral rating will be removed. And below, the table just kind of shows a breakdown of the number of positive and negative reviews and the total data set for each item. You'll see that the positive reviews pretty much dominate the negative views 2 to 1. I performed several text pre-processing steps. The first was to remove punctuation and convert all the text to lowercase letters. I then tokenized the text and applied POS tagging based on UPenn's tagger, and I only kept nouns and adjectives. I also had a list of keep words. These included but, no, nor, not, the letter T, can, don't, don for don't, and should. These are more so sentiment words, and I noticed that I had better results when I actually included them instead of having them removed. I also removed stop words. Now most stop words will be removed because they're not nouns and adjectives, but this is just an additional layer to make sure that these stop words were actually removed. I also removed misspelled words, and then I applied the snowball stemmer, which is a little more advanced than the Porter stemmer, and that is simply just kind of hack off the end of a word. Finally, I removed consecutive duplicate words. I saw some reviews where a person would say, I love, love, love a particular item, and so I would convert that to one single instance of love instead of 3. From there, I created the document term matrix with the unigrams and bigrams, and then I removed any term frequencies that were less than 2. This table shows the number of unique unigram and bigrams per item pre and post frequency reduction of 2 or less. As you can see, by simply removing terms that had a frequency of 2 or less, this had a significant impact on the reduction of the number of unique terms. For example, if you look at the Twilight item, before there was about 110,000, and with that reduction, it reduced it to less than 14,000. I chose 3 different classification models to classify whether or not the text review was positive or negative. These models were decision trees, linear support vector machines, and multinomial naive Bayes. I chose these models for 2 reasons. The first is that these models have been shown to work well with text data, and also it's not that difficult to actually extract the most important features in the model. This is important because extracting those features are the hopefully the features that are most important as far as the product that reviewers find important. I also performed 3 different term weightings, so I did the raw frequencies, the TF-IDF conversion, and mutual information. And then kind of from these 9 different models, the 3 classification models and the 3 term weightings per item, I did a grid search for each one of those variations to find the optimal parameters. Once I had the optimal parameters, I performed stratified 10-crossable validation and pulled out the accuracy, precision, and recall along with the most important terms, and then took the average of those to based on the 10 different folds. This table shows the results for the Hoover vacuum, and as you can see, the support vector machines and multinomial naive Bayes produce the best models based on the accuracy, precision, and recall. Note that the term weightings didn't have that much of an impact, if any, which was pretty interesting. And then to kind of the right of the metrics, you see the top 10 terms. And if you kind of just look at all these terms together, you'll see that it's broken down into sentiment terms, such as great and good and not, but also product features as well. So you can see noisy but. You can see that it mentions that it's a vacuum, it mentions the bag, the filter, the power, the suction as well, the hose, the belt. So these seem to be the features that reviewers are looking at when analyzing this product. For the Twilight book, the performance of the models were very similar to the Hoover vacuum in that the support vector machines and multinomial naive Bayes produce the best results with accuracies high in the 80s, also high precision and recall as well. And as far as the top 10 terms that were extracted, you can see with this that for the most part, again, there's these sentiment words, but you get more into the overarching theme of the book. So you see that there's vampire, romance book, love, girl, even Edward popped up in there. So these are kind of the overall theme of the book, which is great because as somebody who hasn't heard of the Twilight series, could kind of look at this and say, okay, this is kind of what the book is about. But what's disappointing is it doesn't get into depth as far as the story itself, but kind of creates these overarching themes of the story. For the GPS navigator, these results are again very similar to the Hoover vacuum. The support vector machines and multinomial naive Bayes produce the best results with accuracies in the mid-80s. Also, the term weightings didn't have that much of an impact as well. But when you look at the product features, you kind of see that very distinct features of the GPS navigator come out, such as you see screen, map, traffic, the GPS, time. So these are kind of distinct features that the GPS does have. These are the features that are most important to the reviewers. The Draw Something app actually had the worst results. The accuracy for the best models were in the low 80s compared to high 80s and mid 80s for the other 3 items. And when you look at the top 10 terms, mostly these are sentiment terms and not necessarily features of the app itself. You do have draw, which would be expected based on the name. artist as well. But one thing you might be able to infer is that you see that there's people, family, friend, sisters in there as well. So this might mean that this is a great game to play with your friends and family. But for the most part, the features aren't that very distinct as far as in relation to the product. But maybe looking at more, not looking at the top 10 terms, but more terms, something, more features might come out of it. But for the most part, this item produced the worst results. For the Wreck-It Ralph movie, these results are very similar to the Twilight book. As far as the models, again, support vector machines, multinomial naive Bayes produce the best results with accuracies in the high 80s and both high precision and recall. Note that decision trees actually did perform pretty well, whereas most of the other items, decision trees didn't perform that well. So this was pretty interesting that for this, decision trees, had some pretty good results. As far as the top 10 terms, I say this is similar to the Twilight book because you see that again that these kind of overarching themes come out of the movie. And for those who aren't familiar about the movie, it's about old school video games that kind of have like these real lives. It's a cartoon movie, and so you see a lot of video game movie. But I think the one term that I love that came out of this was nostalgic. Because when I saw this movie for the first time, that's exactly how I felt because I grew up with these video games. So it was pretty cool to see the term nostalgic come out of there. But I think it is honestly a great way to describe the movie. But again, nothing very specific, just kind of a general idea of what the movie is about. In terms of the three goals that I had for this project, the first goal, as far as building models that were highly predictive for looking at the review text and classifying it as positive or negative, linear support vector machines and multinomial naive Bayes produced the best results. Which was interesting is that term wings didn't really have much of an impact. I was surprised by this. I thought that mutual information would actually help improve the models, but it really didn't. Also, recall was consistently higher than precision, which I thought was pretty interesting as well. As far as the third goal and the product features, what you kind of got from looking at these various items is that items with distinct features, such as the vacuum and GPS, these product features were found. We kind of saw that with both those items. But items that are story-based, such as the Wreck-It Ralph movie and the Twilight book, these kind of had overall themes and nothing too specific about them. Now, there might be more specific features looking at a larger list of the features that were extracted, but for the most part, again, it was just these overall themes. For the Draw Something app, this interactive item, this did not work very well. I mean, we just kind of got these sentiment words, didn't really get any product features, and this kind of both the two goals kind of feed into the third goal is this overall process worked pretty well except for the gaming app. And as a professor has kind of talked about in her research, this is a whole nother language, and it just kind of indicates that deeper analysis is needed. As far as future work, I would like to incorporate noun phrases, also collocations, and integrating numeric information. I'd also like to apply ensemble classifiers such as random forest to see if it can improve the predictability. Thank you, and if you have any questions, feel free to email me.